Hi there, today we're going to learn about surds. Well, what is surd? An easier way to think about it is, let's say we have square root of 5 and then we have square root of, let's say, 4. So are these two surds? Well, this one is, but this one is not, because square root of 4 is equal to 2. So we don't call this as surd, but we call this as surd 5. Okay? Right. So these are the rules of surds that you have to know. Please remember these rules. These are the two most important formulas that we're going to use to discuss these questions. Take note for this remark. Example 1a. Simplify surd of 45. So how to simplify this? You have watched the video just now, and then you can find a perfect square, a combination of something times something, where that one number must be a perfect square of 45. For example, 9 times 5 is 45. And then since you can separate this as square root of 9 and square root of 5, then this is going to be 3 surd 5. So this is the simplest way for you to write it. But I'm going to show you another method, maybe simpler, how to find, if let's say you have no idea that 45 is a combination of 9 times 5, maybe this number is larger than 45, that you can't think of the factorization and the perfect square number, then maybe you can try this method out. So 45, try to find a number which is a prime number that can divide 45, so it's going to be 5. 45 divided with 5 is equal to 9. Next, 9 can still be divided with a prime number, which is 3. 9 divided with 3 is 3. And then you can also divide 3 again with a prime number, which is itself, and the final answer is 1. Make sure your final answer must be 1. And all of the numbers here must be primes. So this means surd 45 can be written as surd 5 times surd 3 times surd 3. Okay? And since we have two surd 3's, that means we can write it as power of 2. Surd 3 power of 2. And this power can be cancelled off. So your final answer is just 3 surd 5. Okay? 6 surd 7 plus 2 surd 7. How to solve this? You can use the rule of surds, and the rule that you can use for addition is number 3. As you can see, if you want to use this rule, the value inside the surd must be the same for you to add the numbers in front. So for this question, check whether the numbers inside the surds are the same. Only then you can add them up. So since both of these surds are surd 7, then we can add up 6 plus 2. So it's like factorizing surd 7, and then you add the numbers in front. This is going to be 8 surd 7. Next question. This is 5 surd 3 minus surd 27. Do we have the same number inside the surd? No, we don't. So what should we do here is, we have to change surd 27 to be in the form of something times surd 3. So what is this something? So we have to figure out this number by using the simplifying surd method. Okay, so let's say this is 27. Remember, here we have to list down the prime numbers. So 27 can be divided with, Yeah, you can divide with 3, and then 27 divided with 3, you get 9. You can also divide with 3, and then you can divide with 3. Final answer must be 1. So we have 3. 3 is there. So that means you can write this as cert3 times 3 times 3, like this. Remember, when we have 2 of 3's, you can also separate this as cert3 times square root of 3 bracket square, because each of this can be separated as cert3 times cert3 times cert3. So since these two are multiplied together, it can change to power of 2, and this can be cancelled off. So this is just 5 cert3 minus 3 cert3. 5 minus 3 is just 2 cert3. Okay, so that's your final answer. Example 2. Make sure you look at the operation in the middle carefully. This is not plus anymore. This is multiplication in the middle. So to multiply certs, what you do is you just multiply numbers with numbers and certs with certs. So 3 times 5 is 15. And then certs with certs. So 6 times 7. Remember, why did I write like this? Is because cert 6 times cert 7 can be combined to be 1 cert according to the rule. Also take note, cert 6 plus cert 7 is not equal to cert 6 plus 7. This is wrong, this is correct. So 5 times cert 6 times 7 is equal to 42. Well, can you simplify this 42? Let's try to simplify. Remember, here you have to list down the prime numbers. 42 can be divided with 2, and then the answer is 21. 21 divided with 3, and then you get 7 here. 7 divided with 7, final answer must be 1. So as you can see, there's no repeated number here. So of course the final answer will be 2 times 3 times 7. Cert of 2, 3 times 7. So that's why your final answer is just 15 cert 42, because you cannot simplify cert 42 anymore. Okay, example B. You have a bracket here, so that means 8 cert 2 needs to be multiplied with all of this in the bracket. It's the same thing, you just have to expand. Remember, number with number, cert with cert. So 8 times 5 is 40, and then cert 2 times cert 6 is just 12. Then we have 8 times, there's no number in front of cert 2, so it's just 1. 8 times 1 is 8. Cert 2 times cert 2 is just cert 2 square, or cert 4. So this is square root of 4. You can simplify that. And then for 12, you can also simplify it. Remember, writing a prime number here, 12 can be divided with 3, you get 4, and then 4 can be divided with 2, you get 2, 2 divided with 2, you get 1. So since we have 2 repeated number, so it's just going to be cert 3 times cert 2 squared, and this is just 2 cert 3. So a faster way in looking at this is, whenever we get two numbers together, we just write 2, and then if the number is single number, this is just cert 3, and then we just combine these two. This is just 2 cert 3. Okay, so cert 12 can be written as 2 cert 3, plus with 8, and square root of 4 is just 2. So your final answer is just 40 times 2, 80 cert 3, plus 16. For the next question, you have bracket squared. So bracket squared means that you have two of the same things. So we have these two brackets, to solve this, just expand. 3 times 3 is just 9, Z2 times Z2 is just 2, and then 3 times 1 is just 3, Z2, 1 times 3 Z2 is just 3 Z2, because 1 times 3 Z2 is 3 Z2, 3 Z2 times 1 is just 3 Z2. So from here you get 18 plus, now the operation is plus, make sure the value inside the sets are the same, so this is just 3 plus 3, which is 6, and then we have set 2. Okay, remember this is like factorizing the set 2 and then just adding the number in front. Okay, next. Now we don't have any number in front of set 5, but we only have the sets. Take note that both of these brackets have the same numbers, set 5 in front, and then set 2 and set 2 behind. The only difference is we have plus sign on the left side and minus sign on the right side. So this is like a formula that maybe you have seen in school, which is a plus b times a minus b, and this is actually equal to a squared minus b squared. Okay, if you don't believe me, you can just try it out. Set 5 times set 5 is just set 25, or you can also write it as set 5 squared. And then set 5 times minus set 2 is just going to be set 10, plus with set 2 times set 5 is just set 10, and then lastly set 2 times set 2 is just set 2 squared. So the thing squared can be cancelled off, and you're left with 5 minus 2. This 2 has been cancelled off because it's just the same number and minus each other. So 5 minus 2 is just 3. So that's why you can just use this formula, because when you use this formula it's faster. A is set 5, B is set 2, a plus sign in the middle here, and then a minus sign here. So from the formula, a squared, a means set 5 squared minus with set 2 squared. Okay, so from here you just get 5 minus 2, and it's also equal to 3.